Good morning, sir. My name is Jinay Shah and my student ID is 24IT091. Today, I am excited to present our project Smart Streetlights. It adjusts brightness based on motion detection. It works on the principle of basic principles of digital electronics. This presentation will give us the overview of this product. It reduces the energy consumption and it also reduces the light pollution. To begin with, first I will question you that what are smart street lights? Smart street lights are those lights that operate automatically and they can adjust brightness based on the motion detection. They use digital sensors, logic gates, and microcontrollers to operate. But to use them, we need to understand the role of digital electronics because to imply these things, we need digital electronics because it combines hardware and software to create an intelligent, responsive lighting system. There must be question in your mind that why I have used digital electronics and what is the main problem that lies in the traditional street lights. First of all, traditional street lights remain at full brightness all the night, and this leads to unnecessary energy consumption as well as large light pollution. And to solve this problem, I have made smart street lights that respond automatically and they work only when needed, and they can also adjust their brightness as per the requirement, and this solves our problem of large amount of energy consumption and to reduce the light pollution. Here to make this product, I have used mainly three digital components. First, we have used different types of sensors. These sensors convert physical movement into digital signals. Then we have used the light source. It is the main source of the light. LEDs provide the light source and support the digital brightness control. And then we have also used the microcontrollers. Microcontrollers process the input signals from sensors and controls the LED output, and this helps us to control the brightness of the light. Now I will explain the role of digital sensors in our product. I can say that digital sensors are backbone of our product. Digital sensors detect the motion and send signal to the LED in binary form, either 0 or 1. When the digital sensors send 1 to our LED, then the LED is turned on, and when the digital sensor sends 0 to the LED, then the LED is turned off, and that's how LED works automatically. Now I will explain the logic gates and their role in our product. Here we have used three logic gates: AND gate, OR gate, and NOT gate. In case of AND gate, the output will be 1 when both the inputs are 1. In case of OR gate, the output will be 1 if any of the inputs is 1. In case of NOT gate, the output will be 1 if the input is 0, and the output would be 0 if the input is 1. In case of our product, for AND gate, light will be on if motion and darkness both are detected. In case of OR gate, light will be on if any sensor detects motion, and in case of NOT gate, the light will be turned off when no motion is detected. Here is the truth table for a light control. When there will be a motion and when there will be no motion and when there will be no darkness, then the light will be off. When there will be no motion but there is darkness, then also light will be off. When there will be motion but no darkness, then also light will be turned off, and the light will only be turned on when there will be both motion and darkness. Now I will explain the role of microcontroller as the system controller in our product. The microcontroller acts as the brain of our system. It reads input from the sensors, executes logic based programmed instructions, and adjusts the LED brightness accordingly. This automation makes the streetlight system highly efficient. Now to adjust the brightness of the light, we use PWM, pulse width modulation. PWM is a method to vary LED brightness by adjusting the signal duty cycles. By adjusting the duty cycle, we control how much power will be delivered to the LED, and hence we can control the brightness of our LED. For example, 0% duty cycle means that the LED is completely off, while 100% duty cycle means that the LED is at full brightness, and 50% duty cycle means that the LED will be at 50% brightness. Here is the digital circuit design for our system. In this circuit, we have used the three digital components as discussed before. First is the digital sensors. They take digital inputs and feed it to the microcontroller. And microcontroller acts as the logic processor, and it then sends the logics to the LED, and then the LED will work accordingly. Timers and counters. Timers and counters both play a very important role in maintaining our system efficiency. Timers define how long the light will stay on after the motion is detected, and counters keep track of activation for performance monitoring. Here is the workflow of the smart streetlight system. First comes sensor detection. A sensor detects the motion. Then comes microcontroller processing. Microcontroller process the input. Then comes decision making. Logic gets determine the state of the light. Then comes light control. LED brightness is adjusted according to PWM. And at last comes timer management. Timers ensure lights will be turned off after a set duration. Power management in digital streetlight system is very important as well as critical. Voltage regulation ensures a steady supply to all the components. Energy efficiency is achieved by dimming lights when no motion is detected. Additionally, we can use solar panels and that can further improve the sustainability. Here comes the main point: real world implementation of smart streetlights. We can use our product in mainly three areas. First is smart cities, second is highway lighting, and third is campus lighting. In smart cities, we can use IoT and digital circuits for lighting, data collection, and traffic management. In case of highway lighting, motion based light for traffic areas, and this reduce the energy consumption and light pollution. And in case of campus lighting, energy efficient system using digital control for smart lighting on campuses can be used. There must be question in your mind that what are the benefits of using digital electronics in a smart street light system. First is that the energy savings of up to 60% can be done using this system. Second is uh, there will be low maintenance because we have introduced self diagnostic feature in our system. And third is that the product will be cost effective since it will give reduced electricity bill and extended lifespan. There are also certain limitations and challenges in digital streetlight systems. First is false trigger. Sensors may misbehave and produce errors due to animals, weather, or other non target movements. Second is component lifespan. Sensors and microcontrollers have limited lifespan and they require replacement. And third is complexity. Designing, debugging, and maintaining such complex digital circuits can be very difficult. There must be question in your mind that what is the future improvement or what is the future scope of digital streetlight systems. First is AI and machine learning. We can make such models that can uh, make predictions based on historical data or traffic patterns. Second, we can use the enhanced sensors such as lidar for more accurate motion detection and reduce the false triggers. Third is smart networks. We can make such a system in which lights communicate with each other to optimize coverage and efficiency. To implement our project effectively, I follow four stages. First comes planning. In case of planning, we select the components such as sensors and microcontrollers that will be used in our product. Then comes circuit design. In case of circuit design, we design the circuit of our product before actual deployment of the product in software tools. Then comes prototyping. In case of prototyping, we test a small scale prototype product to ensure the functionality. And at last comes deployment. In case of deployment, we install the system in a real world environment and monitor the performance of our product. Now I will conclude our product. By using motion detection, logic processing, and power management, we can create a system that enhances safety while reducing energy consumption as well as light pollution. Thank you for your time and attention. I hope this presentation has explained you that how digital electronics can transform street lighting. Thank you.